Einstein's universe came to town. Yep, the whole shooting box, musicians, scientists and all. But among the audience were a group of Palmerston North Intermediate normal pupils who turned up, gave up their school holidays, turned up in uniform to meet Professor Brian Foster, who conducted Einstein's universe. And the chap responsible for it, really, Warwick Grady, your science teacher at Palmerston North Intermediate Normal School, tell us, how did you manage to persuade those kids to give up part of their holidays and actually turn up wearing school uniform during their holidays to go to a science lecture and concert?
Well, in some ways, the hard part was to cut the numbers down who wanted to attend on that Wednesday night. So we have 700 students here. When I opened it to the school and announced it in an assembly and said I was putting a little group together to attend, those who were interested could approach me. Large numbers did so. And so at that point, I then had to say there are probably more than we can cope with. Those who were really interested have a mathematical or a musical or a scientific interest, or perhaps a combination of all three. They could write me a letter applying for one of those seats and tell me why they should be in the front row. And I had 55 replies in the 3 days that I gave it, and from which I chose 14 who attended on the night. There were just as many again who could have easily attended because many of them wrote really compelling reasons for being there. But the school decided we would sponsor in some way the seats to keep the price manageable.
Right, because there was a charge for the lecture and there was a charge for the concert. Did many kids go to both?
6 stayed for both.
Right.
Yes, and 8 went home after the lecture. And so that meant that most of those second group of people were musicians, pianists, violinists, and so on, and those who had an interest in linking the mathematics and the science and the music together. So they stayed through till nearly 10 p.m, which was a long night for them.
Indeed.
And then they were back the next morning for breakfast.
Yeah, now the breakfast, not all the ones who went to the concert came to the breakfast. I think you had about 10 at the breakfast.
Yes, that's right.
So that must have been quite something for them to actually get up close and personal with Professor Foster.
I think so. It would be a once-in-a-lifetime chance for many of them. Some of them have ideas of careers in science, and not necessarily in physics itself, but in some aspect of science. And so they were really looking forward to making contact and a link, and also hearing options for study at Oxford and options for careers in the future, which he talked about at the breakfast, and a chance to, I think, tie together the man from the night before with what the man does on a day-to-day basis. Because I know you can appear as a presenter, but some of the students might have wondered, well, is that what you do? Is that a full-time job, just presenting around the world? But no, he runs labs and has PhD students working under him. He obviously is a very busy man. And
is often at CERN running their Great Hadron Collider thingy.
Exactly. So there's he's not someone who's just as a television star who pops up for half an hour every couple of nights, earns big money and then disappears. No, he's working 7 days a week, 24 hours a day. And when I contacted him about coming for the breakfast, I rang him on a Saturday New Zealand time and got him after a lecture in Oxford on a Friday afternoon. And it just happened to be his secretary said, you can speak to him now. And it worked just perfectly because I got him. Otherwise, he would have been gone on a plane, and it would have been a case of then sending messages and hoping that he would answer. So it was fortuitous timing, I think.
Timing is everything, isn't it? So how did you find him? I mean, you have perhaps down this neck of the woods, you have an image of an Oxford Don as being someone slightly unapproachable.
Well, I thought so.
So you had that as well. It's not just me.
No,
right.
Very much. I was a member of the Royal Society of New Zealand, and so knew of the upcoming lecture tour, and was watching for things that helped me tie in my science program here in the classroom with the bigger world of science. You may have to wait sometimes 1 or 2 years to get something that matches. So this was very good timing this year that I'm working with physics this year with my students, and we had a physicist coming for the lecture. And so I saw that coming earlier in the year, around about April, and I thought, I want to see if we can, what are the chances of getting some students to that, not knowing whether it's really aimed at this level of the 11 to 13 year level, or was he really aiming at university or adult interest groups and so on. But from what I could read in advance and what I could see on YouTube and so on, it was aimed at the general public, and it was not beyond our students. And indeed, these gifted and talented students that came on Wednesday night, most of them added to their knowledge, but many of them found that they were confirming things that they already knew about or that they'd already investigated themselves in some way. And so it was just perfectly pitched for them. And so I put it together as a package to the students and thought, wouldn't it be great if he had time after the lecture to talk with us? But of course, there was a concert. There was a 1 hour gap for dinner, and then the concert started at 8. And he couldn't feel that he could take that time, the preparation for the concert with the musicians and so on, and talk to our group. And so he then said, well, what about something the next morning? And originally it was going to be a morning tea, but because he had to be in Wellington to go on air at 10 to 1, morning tea became problematic, and so we went back to breakfast, which is what we had, 8:30. And so it gave us the chance then for the students to use the questions that they'd shown me earlier on when they asked to come, and also any questions that had come up on the night that they thought, oh, I'd like to talk to him about that. And it's very hard to know when you're asking cold, isn't it, that you wonder, will he be prepared for that kind of question? Are some of the questions beneath him in terms of, he's used to dealing with people at a far greater level than myself. And so, but he was perfectly fine for the 11 and 12-year-olds. They were really quite able to understand his answers, and then he would ask them a question, and they would look at each other, and then someone would respond. So they were very much on a level playing field with him, I think.
And he didn't just want to ask them about their science knowledge, he wanted to know bits about their lives as New Zealanders too, which
Education
was...
things to visit in Wellington.
Yes, yes.
Where should I go? And of course, for some of the children who go to Wellington often, they have 2 or 3 things off pat. But then after that, they're a little bit thinking, what else would someone really want to see that would be unique to Wellington? And so it also gives them a chance to show knowledge of what they know, which is New Zealand and its culture and geography. So.
And today you get a very good live stream. A lot of particularly older people say, oh, that was completely wrong. And then you get a lot of people who say, oh, I never heard about that before. It's interesting.
Well, you've heard of breakfast at Tiffany's. This has been a breakfast at Bethany's with a rather extraordinary guest. This is Professor Brian Foster from CERN, the Large Hadron Collider, and Oxford University. Welcome to Palmerston North.
Thank you. It's a very great pleasure to be back here. I was here 4 years ago, so it's very nice to come back.
What was your first visit?
We were doing a similar lecture, but actually at the university, so it's nice to be in the city for once.
Now, talking about this lecture, you've been in Palmerston North with Einstein's universe, which is a novel approach because it's science and music.
Yes, it's very good, we think, because it brings in a new audience to science, people who want to hear a great violinist. My colleague Jack Liebeck, who's one of the best violinists in the world, plays some of the music which Einstein loved. And at the same time, I try to explain to the public what Einstein's theories are and how they're relevant to our understanding of the universe and what we're doing to try to go beyond where Einstein got to, so particularly at the Large Hadron Collider at CERN.
And how far beyond Einstein have we got?
Oh, quite a long way. I think if he were alive today, he would recognize the description of the universe that we're building up. But nevertheless, we've made enormous progress. He spent the last 20 years of his life trying to unify all of the laws of physics into a single overarching theory. And he failed, mostly because, in fact, he didn't know many of the things that we now know. So at the moment, we've been able to unify 2 of the 4 forces of nature, and we hope that in the next few years we might find clues which will allow us to go further than that. But the big excitement of the last year has been the discovery of what's called the Higgs particle, which is a remarkable particle, by far the most special particle we've ever discovered. It has completely unique properties, but which we believe is the solution to why particles have mass, and because particles build up atoms and atoms build up people, it's also the solution to why we have mass. So it's a sort of deeply fundamental particle. And last year, almost exactly 1 year ago, on July the 4th last year, CERN was able to announce the discovery of this new particle. And what we're doing at the moment is trying to understand what its properties are in some detail, and that will take several years more of work.
So this, the Large Hadron Collider, it's what, the world's biggest machine? I think you described it during the concert.
That's right. It's 27 kilometers in circumference, and that 27 kilometers is filled with extremely high-tech equipment. The accelerator itself works with what we call superconducting magnets, which are cooled down to just 2 degrees above absolute zero, so minus 270 degrees centigrade, incredibly cold. And at that temperature, the materials which the magnets are made of don't have any electrical resistance, which means you can pass enormous currents through them without them getting hot. And those enormous currents produce a very large magnetic field, which you then can bend the very energetic particles around in a ring, the Large Hadron Collider ring. So that's about 35,000 tons of magnets are down in the LHC itself. And it takes an enormous amount of liquid nitrogen and then liquid helium to cool them down to the temperature at which they operate. And then they themselves feed into the experiments where you take the collisions of the two protons, which circulate in opposite directions and collide at points around the ring. Around those points where they collide, you build very complicated and sophisticated experiments to try to see the products of the collisions and to measure them all exactly. And if you can do that, then Einstein's equations tell us that we can then reconstruct everything we need to know about the interaction. And from that, if we have enough of these very energetic collisions, we can then make progress in understanding what it means about the structure and laws of the universe. And that's what we're trying to do.
Now, that was one of the questions put to you over breakfast. You were invited to breakfast by a group of Palmerston North Intermediate normal school pupils who plied you with food and interesting questions. And one of them was, how does the Large Hadron Collider add to our knowledge of the universe?
Yes. And so I was trying to explain both in the lecture and over breakfast about how we do that. And essentially, as I tried to say, we just look at the collisions as they occur, and we look at in detail in the detectors which surround them. We take the data, we throw away almost all of the data, which is not interesting because we already understand it, and then record it on computer storage and then go back to it and reconstruct what's happened using enormous computing power. And with that, we have the tools in which we can try to understand what it means, what it tells us about the universe.
Why do we need to know?
Yes, good question. Of course, it's part of human culture that we're curious about the universe. People have been looking up at the stars and wondering how they work since the very earliest dawn of time. And those big questions are not only, I think, culturally important, and I would personally emphasize the cultural importance. I think it really is important that we think about how the universe works. But also, of course, they're very important in terms of producing spin-offs. Of course, the most famous spin-off of particle physics in particular is the World Wide Web. That was invented at CERN specifically to allow physicists to pass data around in a very transparent way. And of course, the amount of economic activity generated by the World Wide Web is trillions of dollars every year. So it pays for CERN millions times over. So, and that's just one example of the sort of spin-off that occur when you're pushing technology to the limits, which is what you have to do if you're doing these very technologically advanced experiments. It always brings up new things because you're trying to go beyond the state of the art in all sorts of technology.
And how does that fit in with music?
It's an interesting phenomenon that many of the greatest scientists have been enthusiastic and quite often very accomplished musicians. I'm not sure I fully understand why that is. In Einstein's case, he was a really enthusiastic violinist. He is well known to have been a person who, if he saw someone passing his house with a musical instrument, he would drag them in off the street and play with them. He loved to play chamber music. He loved to play music of all sorts. He particularly loved Bach and Mozart. And I think Bach, it's relatively easy to understand why a physicist and mathematician would somehow have an affinity with Bach because it's music which has very, very strict mathematical rules about how you do particular things, and the complexity of Bach sort of resolves itself sometimes into simplicity. And it's that sort of operation that we're often doing in science, trying to take very complex information and try to see the simple basis of it all. So I'm sure that that's why Einstein was particularly fond of Bach, and many scientists also are. And I think it's the sort of pastime and hobby which scientists find helpful, because very often if you're stuck with a scientific problem, and we have documentary evidence of this being true for Einstein, it helps to leave it for a while, to go away and play an instrument, which is a intellectually very taxing operation, but very different to doing science. Often you find after you've played the violin for 15 or 20 minutes and you go back to your problem, somehow it seems simpler and you can see a solution. And that, I think, is another very important reason why scientists often find music to be very helpful.
And you practice what you preach. You have your own violin.
I do, and I particularly enjoy practicing it, and I tend to practice late at night, actually, and fortunately my wife's already understanding, but she's usually in bed when I practice, and it's a very nice way to end off the day. It's sort of gets things through your mind in a sense, so that you don't go to bed worrying about a particular problem that's been occupying you during the day. You sort of concentrate on something completely different, and I find it a very relaxing way to end the day. But also I must admit that I've become much, much better as a violinist since I was 50, because I now have a great teacher, Jack Liebeck, my colleague, who is a great soloist. He's my teacher, and I think I'm a living example that you're never too old to get better. And I'm certainly much better violinist now at almost 60 than I was when I was 18. So I'm very pleased that I'm still getting better.
Some words of advice for young people who are looking at career options and are perhaps considering maths and physics.
Well, I think it's a very rewarding occupation. I've had a fantastic career, and I certainly don't have any regrets for doing science. And I think that in the coming years, then it's absolutely clear that developed Western-type economies like New Zealand have got to compete on an intellectual level. We've got to be looking at how to give added value. We will never compete in terms of producing goods very cheaply. We have to find ways to really make benefits from our economic and intellectual capital. And I think the best way to do that is to have a highly trained workforce, to produce people who are really efficient and knowledgeable in science. So I certainly think that I would recommend anybody who is interested in science that it's a fantastic career. And I don't know many unemployed physicists.
So it's colliding experiments from the highest possible concentrations and waiting.
And what was the kids' reaction, after the breakfast?
I've had some feedback emails
Yes.
over the last 2 days, and very positive. When can we do it again? What about, can we go to Oxford now and go to see him live? What are the chances of a trip, Mr. Grady? So I imagine it'll spark enthusiasm and interest, and for some of them, maybe out of the 10 or the 14, there may be 1 or 2 who pursue it in some direction after high school. And it would be great to see someone in 10 years' time saying, oh, I'm 22 now and I'm studying in physics at a university somewhere, and I remember it back to that day that I met Professor Brian Foster, and now it's a possible future career for me. So you just don't know what might come out of it. Even if not immediately, it may well be in the future. Could even be as a hobby. As he said to the students, astronomy is a huge thing that people can do in their own backyards with a telescope or a pair of binoculars. And there's still there's still as much to be learned again as what we've already learned. And so it's the opportunities for hobbies and personal interests, as well as professional in terms of careers, it's probably endless. And as he said, he doesn't know of a single physicist who hasn't got a job. So some of the children smiled. That's me.
How did you find it as a teacher?
I found it was a very good summary of things that I put in my own mind together. I didn't know that I hadn't the knowledge of Einstein's life and personal life and links to Rutherford from New Zealand and links to...
It wasn't that fascinating. He tied it all in it. And actually, in fact, he said Rutherford was one of his heroes. Yes,
exactly.
Yes.
Yes. And so I hadn't realised there was such a strong link, but there were the photos on the screen showing Curie and Rutherford and Einstein and all at the same conferences, shoulder to shoulder. And he was able to pick out of group photos, wasn't he? Other important people, the creator of the atom bomb and so on was at a conference. And he was, so those people, you don't think of them as being together in any way, but they obviously had links. Today with the internet, I guess we have instant links, but in those days it was by ship and then by personal one-to-one contact, and probably by writing letters and waiting for 3 or 4 weeks for the reply. So it was a great rounding off, I thought, of what I knew in physics, and for those students it tied it together and gave it a sense of history and a sense of what's gone before. Many of the students know about Higgs boson, and because that was very topical a year ago, and so even mentioned...
By George, I think we've found it.
That's it.
Yes.
And even mentioned that as the possible Nobel Prize in September. And Professor Foster must have thought that there's an insight there, a good chance that could be named. And so those children remember that in September when it comes up, and they'll say, well, I heard that already.
I knew Professor Higgs was going to get the Nobel Prize. Yes.
So it was all a great tie-in, I thought. And I've even been able to think I could use a couple of his ideas in my own physics classes. For instance, creating the shape of someone by using light from behind them.
Wasn't that interesting?
And then if you do it with sound, of course the waves are so big, the sound just goes around the person, and you won't get the same sharpness of image. And I thought, oh, that's one way I could have taught that. I've been trying to show children, but it was hard to imagine how you could do it in a classroom. But I can darken this room, drop the blackout curtains, and put on a light, and then put on some sound as well. So I thought...
Well, you can also, I suppose, get different densities of object to see their sound deadening qualities too, because you can get baffles or something like that.
I thought of a tree branch with leaves on it. That would make a different sound than a solid board. So, I thought sound is a good thing to use because it acts nicely and slowly and easy to do and quite practical in the classroom like we have. So, not a bad thing.
Which sort of leads into what's happening in August, really, and it's science fair season, isn't it? And amongst
Very much so.
The schools. So you're busy prepping some of the kids who are at the breakfast for science fair projects. Is that how it works?
We have a school science fair first, early in August. So all 700 students complete a science fair project or a technology invention they can choose. We have about two-thirds to three-quarters do a science one, and then the remainder do a technology invention. And so that's beginning of August, and from that group we select a number, which can vary from about 50 to 90, to go to the Manawatu Science Fair, which is at the end of August. And that's where they compete against the other schools. They're judged on a Friday evening by experts in that field of whatever science they've chosen. They're interviewed. The judges read the boards and read the logbooks and ask questions. And then on the Saturday night, there's a prize giving here in Palmerston North, which is attended by many of the students and their parents. And we see that as a school occasion as well, so numbers of staff will be there too. And students receive awards in various categories and divisions, depending on what they've entered into. It goes now from primary schools, so there are class entries and group entries from even 5 and 6 year olds, right through to students finishing college or high school, students who are doing Gold Crest Awards for the Royal Society of New Zealand and Silver Crest, so some of those are 16-year-olds, they enter as well. So it's quite hard to do very well in if you're an 11-year-old, but it's not impossible. And indeed, I have a winning project from last year over there, a girl who created a cream from kawa leaves, which keeps insects away. And so that's now sold commercially, and she has the intellectual property right to it, so she gets paid per jar sold around New Zealand, and she's working on a variation of that this year as a spray that can be used. So some students do very well and create themselves a little niche for the future. Others will do something that they can manage at home, whatever strikes their fancy. And it may be that it doesn't go well this year, but they come back next year as a year 8 and say, I'm going to do a bit better. I've got a new idea, or I can improve my old idea. So it's the one time in the year really that science really gets to the fore in the school. And that Einstein lecture on Wednesday night was a great lead into the whole sort of process that's coming up.